There is a moon in the solar system that looks as if a world was built too quickly, and the evidence was never erased. Its name is Iapetus. It orbits Saturn, and at first glance, it already seems wrong. One side is dark like charcoal, the other is bright like snow. But the strangest thing about Iapetus is not its color. It is the wall. Running almost exactly along the moon's equator is one of the most bizarre landforms ever found on any world. A giant ridge system. In some places, it rises to around 12 miles high. It stretches for hundreds of miles, and it follows the equator so precisely that it does not look like ordinary geology. It looks deliberate. It looks like a seam, as if two halves of a moon were joined together, and the weld was left exposed. That is what makes Iapetus so unsettling. On most planets and moons, the equator is just geometry, a coordinate, a line on a map. On Iapetus, the equator became physical. It became structure, a wall, a scar, a mountain chain aligned with such precision that planetary scientists have spent decades trying to explain how anything in nature could produce it. When Cassini returned its first close views, the mystery did not get smaller. It got worse. The ridge was not a smooth bulge. It was narrow, steep, jagged, and in places absurdly tall. If Iapetus had simply spun faster in the distant past and later slowed down, that might explain a broad equatorial swelling, but not this. Not something this sharp. Not something that looks, in many places, less like uplifted crust and more like material piled onto the surface. That is why the mystery split into two major explanations. Either the ridge came from inside Iapetus, through tectonic or rotational forces, or it came from outside, from debris that once orbited the moon and later crashed down along the equator. The internal idea sounds simpler at first. Iapetus almost certainly did spin much faster long ago. Its overall shape still seems to preserve part of that ancient rotational bulge. But the ridge itself is too narrow and too steep to be explained cleanly as nothing more than frozen geometry from a faster spin. The shape is too specific, too concentrated, too much like a deposit. That leads to the more spectacular idea, and also the one many researchers take very seriously. Billions of years ago, Iapetus may have had a ring. Not a ring around Saturn, a ring around the moon itself. In that scenario, something violent happened early in Iapetus's history. A large impact may have blasted debris into orbit. Some of that material may have formed a temporary ring close to the moon. Some of it may even have gathered farther out into a small sub-satellite, a moon of a moon. Over time, the ring material would not remain suspended forever. It would spread, lose orbital energy, and begin to fall. And because orbital debris around a moon falls preferentially along the equator, it would land exactly where the ridge is. That is the power of the ring fall idea. It does not just explain why there is a wall. It explains why the wall is on the equator. The equator is not a background detail here. It is the central clue. If debris rained down for long enough, mile after mile, it could build an equatorial ridge from above rather than from below. Not a wrinkle in the crust, an accumulation. Not uplift, but accretion. A former ring, slowly collapsing onto the surface and leaving behind a fossil wall. And there is evidence that points in that direction. Measurements of the ridge slopes show that some faces are extremely steep, close to the angle expected for loose material piling up under gravity. That matters, because it makes the ridge look less like solid crust shoved upward, and more like debris emplaced onto the surface. In some of the most important places, it really does look like a pile. But that explanation has its own problem. A pile of icy debris up to 12 miles high should not be easy to preserve. Ice is not permanent in the way rock is. Given enough pressure and enough time, ice can deform. It can flow. So if the ridge formed from falling ring material, why has it not relaxed away over billions of years? The answer may be that Iapetus froze early and froze hard. Unlike moons such as Enceladus or Europa, Iapetus is far enough away that it escaped the strong tidal heating that can keep icy worlds geologically active. It seems to have become cold and rigid very early in solar system history. If the ridge formed after the moon had already developed a thick, strong outer shell, then the surface could support the load without sagging much. That would make Iapetus not just strange, but ancient in a very specific way. It would mean the ridge is a preserved relic from a time when the moon was already mechanically stiff enough to keep the evidence. And the evidence really is ancient. The ridge is heavily cratered. That means it has been there for an immense span of time, likely at least 3.5 to 4 billion years. This is not a recent event. It is a fossil from the early Saturnian system. From an era when collisions were common, orbital evolution was violent, and moons may have passed through configurations that no longer exist today. That alone would make Iapetus extraordinary. But the moon has another layer of strangeness. Its color pattern is one of the most dramatic in the solar system. The leading hemisphere is coated in dark material. Much of the trailing side and polar regions are bright. This contrast is not just visual. It reflects a process in which darker areas absorb more sunlight, warm up more, and cause surface ice to sublimate. That vapor then migrates and freezes in colder regions, making bright areas brighter and dark areas darker. It is a feedback loop, and over time, it turns a modest difference into a planetary scale divide. So Iapetus is not just the moon with the wall. It is the moon with the wall and the split face. That combination matters because it suggests a world that preserved ancient conditions instead of erasing them. It is geologically quiet, thermally unusual, frozen in time. In many places across the solar system, early evidence was buried, melted, resurfaced, fractured, or recycled. On Iapetus, the record remained. That is why the ridge still resists a simple answer. A purely internal origin struggles to explain the narrowness and steepness of the structure. A purely external origin explains the alignment and the piled morphology more naturally, but still depends on a very particular sequence of early events. The most honest conclusion is that the ridge probably records more than one process. Iapetus may first have acquired the right overall shape and internal state through early spin and cooling, and then later received an equatorial load of infalling debris from orbit. In that picture, internal evolution prepared the stage, but external debris built the wall. That hybrid possibility is part of what makes Iapetus scientifically so important. It shows that worlds are not always shaped by one clean mechanism at a time. Rotation, impacts, ring dynamics, thermal history, lithospheric strength, orbital evolution, all may have left fingerprints on the same moon. The ridge is not just a mountain chain. It may be the surviving record of a world that once spun faster, may once have had a ring, and then froze before later processes could erase the evidence. If that is true, then Iapetus may preserve something far bigger than the history of one moon. It may preserve a process that happened elsewhere too, but was later destroyed. Other moons may once have had temporary rings. Other icy worlds may once have carried equatorial seams. But on most of them, time removed the proof. Iapetus may simply be the rare place where the solar system forgot to clean up after itself. That is what makes the wall of Iapetus so extraordinary. It is not just tall. It is not just strange. It is a surviving trace of a messier solar system than the smooth textbook version. A solar system shaped by impacts, orbital decay, frozen relics, and structures so improbable that one of the best surviving examples now stands 12 miles high on the equator of a moon orbiting Saturn. On most worlds, time softens the story. On Iapetus, time left the seam exposed.